No locks. Alright, so we ready to get started?
Yeah, man, that's the smallest crowd.
Honestly, I'm thankful anyone showed up. He doesn't have to use this topic, so.
Good stuff.
Alright, so that's good. I don't know how to fix this, we'll just keep on going. Okay, so just first an overview of what I'm going to talk about, just in case it's not quite what you expected. I'm going to give a slight overview of the ICS environment. A lot of you guys probably know all about that, so you're going to be bored to tears. Some of you might not know anything about that, so you're going to be bored to tears. Then I'm going to get into the meat of the presentation, Sixnet Universal Protocol, which is really what's vulnerable here. And then some fun stuff to do with it, and the tool I created to do that fun stuff. And then we're going to get into a little bit of defense. So, a little bit about me first. Or wait, hold on. I was sitting in some of the other talks, they had a lot of buzzwords. I didn't have any. So here's some buzzwords. Feel free to take them in. Software as a service. Alright. So a little bit about me. I'm a doctoral student at the University of Louisville. Also a graduate research assistant in the Intelligent Systems Research Lab. This project that I'm presenting today, it was my master's project in the spring. And this got the attention of some of the professors in the electrical engineering department. I don't know if you're familiar with Dr. Graham. So they invited me to stay on to further this project and further some other projects that they're working on. And scholarships, so free school, it's awesome. Why not? Let's keep on this train. I'm also a bourbon enthusiast. I mean, I grew up in Columbus, Ohio. Thought, vodka's cool, but I'm in Kentucky now. It's time to graduate to some bourbon. It's delicious.
We might test you after this now.
What's your favorite?
Woodford Reserve.
Oh.
What? Did I pass the test already?
Go ahead.
Snobs in the back.
It's all good though. It's so expensive. It's not good.
Are you an Elijah Craig?
No, for all around about bourbon has been Maker's Mark.
Maker's Mark, yeah. It's such an expensive hobby for
most. For mixing up all around.
Yeah. That's going to be my next drink then.
If I was a snob, I'd say Pappy Bamp.
There you go.
Yeah.
Alright, so Sixnet Tools. This is the name of the toolkit that I created. And I got into this project because I was looking for a master's project. I was looking for something that hadn't been done to death. Web penetration testing has been done a whole lot. And Jeremy Druin, I don't know if you got his talk today. He's very good at it. He can tell you anything that you want to know. So asking around professors, Dr. He, professor in the computer engineering, computer science department, said that he had some SCADA tools in his lab. So it's like, all right, let's see what we can do with these. I went into the mindset of, here is the device, the RTU. I want to break into it, and I went from there. And it was a smashing success, and here I am talking about it. So let's get started. The first overview, ICS. You guys know what ICS is?
Industrial Control
System. Yeah, you got it. These are the systems that would govern the operation of a power plant or Toyota's plant somewhere around here. The ICS would control all of that. They would control systems spread over a wide geographic area, such as power grids and water treatment plants, things like that. More specifically, SCADA, which is you got it. You guys know what's up. These are so ICS is general, overreaching. SCADA is a subset of that. It's more the geographically spread, like the power grids, things like that. So HMI, we're on a roll. Come on, you got it. HMI. You guys know what's up. Yeah. See, given the socket DerbyCon, not as many people knew what these acronyms were. This is basically the GUI that the operators in the plant can use to send commands or monitor what's going on at the substations or throughout the plant or whatever that they're working on. For Sixnet, this is the Sixnet IO toolkit. You can see here that if there's one station in this network right now, you have up to 256 stations. Actually, 255 in the master, I believe. You can upgrade firmware, you can verify configuration settings, you can set network settings, you can monitor the input and the output, all from Sixnet's IO toolkit. Here is an RTU. This is the one in the lab. This is the one that I threw electrons at to see how they bounced off. And the traditional definition of RTU is like a microcontroller. It's very simple. All it does is read input and output of some industrial machine that's attached to, and maybe it has a radio to send that over whatever networking equipment you have. It's very simple. Not a lot can. There's not a lot you can really do with it other than what it's specifically designed to do. That specific piece of machinery is connected to. You might notice on this one there's some Ethernet ports up there. There's some serial ports down there, and there's some other. Well, the point I'm trying to make here is that this RTU and RTUs, I guess nowadays, are getting so more complex. They're almost bordering on what PLCs can do, which are, PLCs can run an entire plant. This RTU is not quite that way, but it's getting there. For one thing, it's not a microcontroller; it's an actual processor. It's running Linux 2.6, and it's running Sixnet's proprietary software as a kernel module over Linux 2.6. So just a brief review, we got the operator on his HMI up there. He's sending packets lightning bolt style over to the RTU, which is over at the substation, controlling all these. And exactly what those lightning bolts are, we'll get into in just a second, how that works. But this is the basic. Now, you might have some more operators, you might have some more RTUs spread out around there, you might have some more ways of communicating. But that's the basic overview of what my attack surface looks like. So those lightning bolts, those are generally they're Modbus. There's a dozen or so, 2 dozen different communication protocols. What do you guys use?
Modbus.
Modbus? You all use Modbus? There's some more out there. ENP, ICCP. So Modbus is what the de facto standard's been around since the 70s. Here are the opcodes for it. You guys are probably familiar with this. You have basic read coils, write registers, read registers, diagnostic information. There are some other opcodes that are reserved for extending the protocol, and this is great. So you take away all the security, you put an engineer hat. This is great. It's simple. It's extensible. It's been around since the 70s, so it's working. I mean, we're still using it. Here's the basic rundown of a packet. You have the address, which is the station address, not the IP address. A lot of times these go over serial, which doesn't have IP address or anything like that. And the opcode, which is what we saw before, the data in that opcode. So, for example, if it's a read coil operation, the data would be coil number 1, and then it returned the data. It returned the results from coil number 1. And the checksum is just to validate that no bits were flipped during transmission. So, take off the engineer hat, put on the security hat. Do you see a problem here?
Security. So the validation between the controller and the host.
Yeah, exactly. There's no validation at all.
Anything can run.
There's no way to tell if whoever sent this packet is supposed to send this packet. There's no way to tell if this packet is even a valid Modbus packet. There's no way to tell if it is the right person, if they're even allowed to do that. And this, I guess back in the 70s and the 80s, this wasn't a huge problem when the networks weren't intertwined and RTUs were just like, back when the industrial control network was the industrial control network and the corporate network was the corporate network, everything, there was no connection in between, they were all separated. This was manageable, I guess. Also, back when the RTUs were just microcontrollers and they couldn't really do much anyway. So now we enter the Sixnet Universal Protocol. It's a little more complex. You have the lead, which determines the encoding. These are all 1-byte fields, all the way down to data and then CRC. So the length is the length of the packet. Destination and source is, destination source is pretty self-explanatory. Session and sequence. These are present in TCP packets, and they're not necessarily always used. I'm not quite sure why they're there because Modbus, as well as Sixnet's Universal Protocol, it's always call and response with the packets. The RTU will never send you a packet unprovoked. You always got to send a read, it'll send a response. You send a write, it'll send a response. So I'm not quite sure why there's sequence and session and it's only one packet back and forth. But it's it's there. Anyway, so then we have the opcode, just like in Modbus. We have data, just like in Modbus, and the ZRC, just like in Modbus. The opcodes we will get into a bit, but as you can see, this has the exact same problem as Modbus when it comes to security. There's nothing in there for authentication, nothing in there for authorization or anything like that. There's nothing in there to handle encryption, so all this is plain text over the wire. So let's go into how I found this opcodes. Broke out Wireshark. This is all over Ethernet, by the way. And 11 million packets later, and plenty of frustration. You can read through those comments to see how frustrated I was trying to debug and reverse what all these numbers meant. I mean, this is pretty much what a packet looked like going over the wire. Just this bunch of hexadecimal characters. Going over Ethernet, by the way, it's all over UDP. It's all over port 1561, I think is Sixnet's port. Wireshark recognized that, by the way. So I eventually, after all of this headache, I eventually got a prototype Sixnet Universal Protocol driver written by me, so I didn't have to go through the HMI or anything like that. And the reversing process was actually using the HMI, sending all that traffic through Wireshark, and then picking and choosing the packets out of there. So let's see what kind of trouble I got into. First of all, okay, this function is just a proof of concept. All it really does is make the lights blink. Here, I'll show you the blinking lights over here. So right here, these are the digital outs. The first pin on digital out is 1, so the light's on. So that function, all it does is set the digital outs on and off, makes the lights blink, makes it a little flashy. It's good for a demo, which I don't have a demo because demos go wrong. So you just have to trust me how this works. So that was the proof of concept. Got it working through my driver, not through the universal, or not through the HMI. So let's see what else we can do. Telnet and FTP. Now, since this is running Linux 2.6, Telnet and FTP, they're part of the operating system. That's they're enabled there by default, and that's a problem. So for Sixnet, that's not a security problem; it's a licensing problem. For whatever reason, I guess to create artificial tiers of licensing, they don't like to enable Telnet or FTP by default. Their program running on the RTU is a kernel module, so it listens on the Telnet and the FTP port, and intercepts those packets, and depending on your license, will let those packets actually hit the services and respond. If you don't have the license, and you can scan that device all day, it'll tell you those ports are open all day. You can send packets at them all day. No matter how much you scream, they will not reply. However, Dr. He, which is the person I'm working on directly, said he was able to work around this before, so I kind of went to poking around, and I found this general config file. This, by the way, is a file operations window. It's in the HMI. These are the files that are on the RTU. I found this general config right here, and if we crack that open, we will see right here, enable FTP equals 0, enable Telnet equals 1, enable www equals 0. So all you have to do through the HMI is go in there, set those values to 1, suddenly FTP is enabled. Set Telnet to 1, suddenly Telnet's enabled. If Sixnet goes through this much trouble to protect their licensing and their cash flow, you can probably see how much trouble they go through to secure the device. You might see where this presentation is going to go. By the way, I have no idea why an RTU would need a web interface. I have www, whatever. Anyway, let's do some more. So, get file descriptor. Going through the packets in Wireshark, I saw this line go through, /etc/stac config /general.config. That is a file path. So, cracking that open, I found this opcode 1A, which is file manipulation, and this the sub opcode 03 gets the file descriptor. So you send over 000300. I don't know why it's so many bytes in the file path, and it'll return the file descriptor that the file path you're looking for. If you're trying to write a file, you send over the file size you're going to write and the file path where you want to put it, and it'll create that file and send you back the file descriptor. So what can you do with the file descriptor? Not much, except for this other opcode. Oh, this is the reply, by the way. 01 is the acknowledge, and then the data and the reply packet is the file descriptor. So there's this other opcode, or sub-opcode, 06, that actually lets you read the file and write to the file. So if you want to read, you put 06, the file descriptor, and that's it. The RTU will reply, let's see, here's on the way back, the RTU will reply with the file descriptor, the index of the file that's going to start reading, the length of what it's read in the packet of the data. The Sixnet Universal Protocol packets are they're limited to about 240 characters in the data section. So if you're reading a file that's more than that, and you probably are, you have to send multiple packets, multiple requests to read that file. In the subsequent requests, you start from where the last request ended, as far as, we'll go back. Where the last request ended, right here in the read. So the start would be 241, and the next one would be 482, and so forth. And it's the same for write, just in the opposite direction. So some more sniffing. So that's okay. That's file manipulation, reading and writing files on the underlying file system, which is bad. Some more sniffing, and I came across this in Wireshark. Cat etc Sixnet info.txt. Cat. Does that ring a bell to anybody? Setting off red flags or anything like that? That is a Linux command to print the file to standard out. So that's printing out netinfo or Sixnet info.txt to standard out. That is probably not a good thing either. So that brings us to the next subcommand that I found. These are all undocumented function codes, by the way. Shell commands. Opcode is D0. That 1E0100. Does anybody recognize that? It's a trick question. I don't know what the hell it means either. But so you put those in to the data, followed by the command that you want to execute in an alternator. And here's the reply. Has that acknowledged? Has the length of the reply and the output. So you create those packets, you encapsulate that into a while loop, and you have a Pseudo-Shell on the device. And this, you can't really see it because it's cut off, but this prompt says root, and that's accurate. When I launched the Pseudo-Shell that I wrote, it actually sends who am I to the device, and it prints, and it uses that prompt right here. So this is actually a root shell on the Sixnet device, just using the Sixnet protocol, nothing else. And nothing's really changed on the device. I don't have any code sitting on the device. This is all through its the software that Sixnet put on there. So that leads to probably my favorite thing to do with the device. Cool, it's cut off. You can't really see what's going on. So my favorite thing to do with this newfound power is I cracked a packet that looks kind of like that. Okay, let's see it. We'll print that out. Does anybody recognize that? No? That is the command for a Furk Bamp. You guys know what that is? It's okay, speak up. No? This Furk Bamp, it's a fun thing to do to your friends who use Linux. What it does is it creates a process whose job is to create more of itself. So it creates a process that creates processes that all create processes that all create processes until the operating system crashes. This is the reply back to that. You can't see it, but it's 0, 1 over here. So the RTU says, okay. Then it starts creating those processes until it dies. Then it needs to be physically cycled on and off. Power needs to be reset. That's the only way to bring it back up. So that can effectively break the device until an operator can drive out however many miles to the substation and cycle the power. That can cause bad things to happen. That would be fantastic. Okay. All right. So here is what my Sixnet tools looks like. That's the command line written in Python. Here are some of the things it can do. Okay, H displays this help dialog, but -S, it'll scan the network for Sixnet devices using just Sixnet's protocol. I don't have any real live data to back this up, but I don't think many IDS or IPS devices are monitoring for Sixnet protocol packets going over the network. And this will just send one to each in whatever block that you give it. And what the Universal Protocol does when it gets a NOP, which is a no-op, it'll just send a command, it'll just send an acknowledge with no data in it. So this is like 10-byte packet that it's sending over, and it's getting back an 8-byte packet, tiny packets, just to get a number from Sixnet devices. The big T, it enables Telnet on that given device once you find it, which we went over. -F enables FTP. -lowercase f will get the operating system and the firmware information for that device, so you know exactly what you're looking for. Although in this case, this vulnerability is present in every firmware from the latest all the way back. Sixnet knows about this, by the way. So it doesn't really matter what firmware it is; it's going to work. -uppercase S is that Pseudo-Shell that I just showed you. -R will write a file. It'll copy a file down from the Sixnet device, so you can copy the whatever alerts it has set on it. You can copy whatever ladder logic it has on it. I want to say you can copy the firmware down too and mess with that. I don't think you can write the firmware solely using Sixnet over Ethernet, which is what this supports right now. I think you can over serial. Anyway, and the W will write a file from your machine to that machine. So if you have an exploit you want to load up there to start scanning and exploiting the network from that RTU. Can you imagine if your network was getting attacked from an RTU in a substation a million miles away? It's not really something that you would expect. Anyway, -P will clear the password for the for whatever user's running the Sixnet software, which most likely is root. So you can clear the root password. I can't set the root password, but I can clear it. And -L is that Blinkenlights thing. It's all fun. And the -B is Furk Bamp, which is my favorite thing to do ever. So that's my Sixnet tools. Any questions?
How long did it take you to write that?
A couple months. I mean, it was mostly trying to figure out what the hell all those numbers meant in the packets. I mean, that was where most of the frustration was. Anything else? I have another question for myself, just to get you started, just to get warmed up.
You said Sixnet knows about this?
Oh yeah. So that leads into it. How do I mitigate this threat? Pretty good looking question. So before I originally made this talk for DerbyCon, which was last week, which is awesome. You guys should go to DerbyCon if you've never been. But before I did that, we reported this to ICS cert, which is we can report it anonymously, and they'll send the report to Sixnet and on behalf of us, just for legal protection. I'm not saying Sixnet would do anything, would sue me for trying to break their software or anything like that. I'm not saying it was just in case. I've heard horror stories about white hat testers getting sued. Anyway, Sixnet was super cool about it. So I sent it to ICS cert. ICS cert gave it a nice CVE with a bunch of scary numbers. It's got an exploitability score of 10. Not sure what that means. Impact score of 10. Don't know what that means. Base score of 10. Not quite sure what that means either. It's all what? Yeah, and authentication not required. Access complexity low. Network exploitable. A whole bunch of scary numbers that apparently they think it's a big deal. Sixnet responded saying that we're not using the absolute latest firmware. They have some firmware that they created especially for a specific client that deals with all these issues. It adds authentication, authorization, and enter Sixnet firmware 4.8. It adds all that stuff, and you can even limit the actions that you can do on the device based on user and specific actions. So, for example, admin can do everything. User 1, maybe he can only read the coils. User 2 might be able to read and write the coils. User 3 might be able to read everything and also send some administrative commands like the shell commands. So you can set that up. And does it work? It works very well, actually. I was careless in the lab once I got this firmware, and I accidentally locked myself out. So I had to wipe the firmware and start over. That was about a day of lost productivity in the lab. Anyway, and some angry looks from the professor. So yeah, okay, it limits. You can limit on a case-by-case basis what exactly you want it to do. However, this firmware, this is Sixnet's site where you can download the firmware even if you don't have a license, if you don't have a device. You can just, anyone can go down and go over there and download it. This screenshot was taken last Thursday, or no, last Friday actually. This is live on their site, firmware version 4.3, which is completely vulnerable. All the versions before that are completely vulnerable. So it's not, this new upgraded firmware that solves all these problems is not available yet. The only way I got it was I went and bugged Sixnet for it. I mean, they were nice about it, but it's not available. You have to go bug them for it. And honestly, if you're an operator on an ICS network, I probably wouldn't implement beta software on my network anyway. So you're kind of stuck. This vulnerability is probably going to be exploitable for the foreseeable future. I don't know what to tell you about that. I was experimenting with some snort rules and things like that, but this firmware solves everything. It's from Sixnet. You just have to wait for it and then test it out yourself. So, for this time, any questions? This is a link to the code on Google Code. It's open. You do whatever you want with it. I'm sensitive, so don't make fun of my crappy Python. I put my heart and soul into it. And there's my contact information. So, that's all. Thank you very much.
Thank you.
Are they going to give you access to PLCs and
Really depends on what's implemented. And I think we do have some Allen Bradleys over there. And those are going to be used for ICCP once we get there, for basically the same as this, and seeing what else we can get to on Allen Bradleys. I haven't had a chance to get into it yet. And honestly, I think the first future work would be trying to break all the authentication authorization that Sixnet put into the 4.8 firmware, and then reporting back on that. That's the immediate future work for this thing. If you guys have any extra PLCs that are just laying around. All right, thank you very much.
Thank you.